Rightio, back with question 29 here. Millie and Molly setting out on the Rogaine course at Ironbark. So let's get a little picture happening. Here's north. And 50 degrees. On a bearing of 50 degrees, they set out for a distance of 3 kilometres. So estimating where 50 degrees is, remember, always measuring in a clockwise direction from north. That's 50 degrees. I'm going to make that 3 kilometres long. Again, this is not a scale drawing. This is just an approximate one. That's fine. They then go due south for 3.9 kilometres. So south, opposite direction to north. So that was leg 1. Second leg, 3.9 kilometres. Yeah, perhaps I drew that a little bit long. Doesn't really matter. Draw a diagram to illustrate the course taken. Yeah, well, that's okay. So let's call this start. That's station 1, end of the first leg. Station 2, end of the second leg. Calculate the bearing of the starting point from the end of the second leg of the course. So I need to find the bearing from here back to there. Remember, my bearing will be from north, which is obviously still up that straight line, around in a clockwise direction to that angle there. Okay. And the distance. So I also need to find that distance there. So I'm going to call that distance D and the angle theta. That seems pretty reasonable for me. So what are we going to be able to use to help us figure this out? Well, we've got a little bit of information. So all the blue stuff was really given. Let's add in what else we know. Well, if this is 50 degrees there, and it's north, and this is a north-south line, then using my alternate angles, this angle here is also going to be 50 degrees. Does that help me? If I've got two sides and the angle in between, what rule can I use? Hopefully, you're thinking cosine rule, aren't you? I could also use the area of a triangle rule, but we're not after the area. So yes, cosine rule. Usually we write our cosine rule like this. A squared equals b squared plus c squared minus 2bc cosine of A. Well, remember that the A is a side length and cosine A is the angle in between the other two sides. We can figure out what to do for this one. So I'm going to have, in this case, d squared, the distance I'm trying to find. That's equal to 3 squared plus 3.9 squared minus 2 times 3 times 3.9 cosine, and we've got the angle of 50 degrees. All we've got to do now is type that in our calculators, find the answer, and we will be done. So I will find my calculator and bring it up. Now, of course, we want to go into menu, and we want to run this. That's all good. What we want to be careful of is we need to go into our setup and make sure we're in degrees mode. So remember your graphics calculator, we've got to switch between degrees and radians. This is it. Angle in degrees. Make sure we're in degrees mode. We are good to go. So let's go ahead, and you can see I typed it in there earlier, but let's just do it again. So 3 squared plus 3.9 squared minus 2 times 3 times 3.9 multiplied by the cosine of 50 degrees. Well, graphics calculator will cope with that fine. D squared is approximately equal to 9.168. Does that seem reasonable to you? Yeah, 9.168769933. Okay, I didn't round, I truncated. Because I've written approximately equal to, and I'm keeping the whole number in there, that's okay for now. You don't need to worry about rounding at that stage. What we'll do is we'll just round off at our final answer. So, from there, 9.168, what do I need to do? Well, obviously, D is going to be the square root of that. So, D is approximately equal to, and we just find the square root on our calculator, which of course you can go Shift and the little square root button, or let's bring in a bit of our index laws. Square root is the same as the power of 0.5, or 1/2. We knew that. So the square root of 9.168 is approximately 3.027, so let's call it 3.03 kilometres. That will be fine. Does that seem reasonable? Well, this is a 50-degree angle, so in a equilateral triangle, that'd all be 60 degrees, and they'd be roughly equal. 3 kilometres, 3.9, that'll be a slightly bigger angle. Yeah, that doesn't seem unreasonable to me. 3.03 kilometres seems not so bad. Let's go ahead now and calculate the last little bit, which is, of course, finding the distance back, and I'm going to use little alpha here as my angle that I need to find. So let's go ahead and use the sine rule. I could use the cosine rule or the sine rule. Let's use the sine rule. I'm looking for alpha, so I'm going to put that on top. Remember, what is our sine rule first of all? Well, it's sine A over A equals sine B over B. And we're all pretty comfortable with that. Fill in what we know. So the sine of alpha divided by the opposite side length, which is 3. That's going to equal the sine of 50 degrees divided by the opposite side length, which we just figured out was approximately 3.03. So you can see alpha is going to be pretty close to 50 degrees because those side lengths are pretty close. All right, what do I do now? Multiply by 3, so I've got the sine of alpha equals 3 sine 50 divided by 3.03. I'm going to work across the page. In your exam, please just keep working down the page. I'm just trying to keep it all nice and clear for you guys so you can see it all in the video here. So what do I do from there? Sine of alpha, 3 sine 50 over 3.03. To undo the sine function, we do the arcsine function. So the arcsine of 3 sine 50 divided by 3.03. This is obviously going to be an approximately equal to answer. Let's go ahead and see what we get when we do it on our calculator. So I've got that number in there. I'm going to keep that number in there. So even though I round it off here, keep the full number if you can. All right, arcsine. Remember, on your calculator, they're a little bit lazy. They just call it sine -1, where the -1 is supposed to mean inverse. We've been through that in my class. If you want to ask me about it, I will happily tell you why I prefer the terminology arcsine. Basically, it's because it is unambiguous, which is always a good thing with our maths. So the arcsine of 3 multiplied by the sine of 50 degrees. Now, I want to be really careful here and make sure that when I divide by 3.03, it's not just dividing the 50. So I'm going to go back in and add another set of brackets. Whoop, too far. So that's 3 sine 50, making sure that's all in the numerator. Last answer there. I can just do it that way. So that's now going to be 3 sine 50 over the approximately 3.03. The arcsine of that, we go ahead and push our button, and it says 49.37. So approximately 49.4 degrees. Does that seem reasonable? Well, it's got to be pretty close to 50 and slightly less than 50. This length was slightly more than 3, and the angle was 50, so this is slightly, well, this is 3 instead of slightly more than 3, so it should be slightly less than 50. 49.4 sounds good. Am I done? No. What did it say the asked us for? The bearing of the starting point from the end of the second leg. So we finish off, well, so therefore the bearing is going to be what? 360 degrees minus 49.4 degrees, which is approximately 310.6 degrees. And so you finish off with a nice little sentence, therefore Millie and Molly approximately 3.03 kilometers from their starting point, which is at a bearing of 310.6 degrees from the end of the second leg. And there you have it. Problem solving question. Drawing a diagram is going to get you some points. Make sure you make a start. Have a go. Think about what information you've got, what rule you can use. Get comfortable doing this. There's plenty of for question 30. Bye.